Thank you all for coming. We're going to have a great show for you tonight. We've got lots of good information to present. And really glad you could give us some of your time and help us come and help us spread the word beyond tonight about all the information that we'll be presenting. My name is Laurie Stevens, and I'm on the board of the Maui Nui Marine Resource Council, as well as on the steering committee for Hui Okawaiola, the group that's doing the data collection. Hui is a partnership between the Maui Nui Marine Resource Council, the Nature Conservancy, and West Maui Reach to Reef. I got that right? And we've been collecting water quality data on Maui for quite some time. You'll hear more details about all of this as we go along. And we're going to present all this great information tonight. Let me just quickly name our panel for you. We have Alana Jurkinen, who's with the Nature Conservancy. We have Kim Polinsky, who is with the University of Hawaii and the Nature Conservancy. And we have James, who is with the Marine Resource Council and is the program manager for the data collection effort. And we have Toba Calendar, who's the CEO of the West Maui Reach to Reef. And with that, I will hand it off and we'll get on with the presentation.
As Larry said, my name is Alana. I work with the Nature Conservancy, and I have been with Hui Okawaiola since we started data collection, which was actually in West Maui in June 2016. So the Hui has given a couple presentations in West Maui. I'm curious if anyone has been to one of a Hui presentation before. Raise your hand. All right, a couple of folks. So that's good. We can give a little more background on how we operate and the kinds of things that we measure. We'll jump in. So as a brief glance at our agenda, we'll start with an overview of how Hui Okawaiola operates, why we exist in the first place. We'll go to Kim for some technical information on what we sample for and why we sample, how we sample. We'll go to James to explore what we're finding and dive into the data. And then to Toba to explore what are the next steps given all of this information. We'll have an opportunity for question and answer, so if something piques your interest as we're talking, stow that away, and we'll have a lot of time to munch on those questions. And then we get to have fun interacting with each other in some breakout stations. There will be 4, including a sampling station where you can actually play with some of our monitoring gear, a station to learn how to get involved. If you are so excited to volunteer, we can definitely help you do that. If you would like to support us in some other way, we can chat about that too. And then of course, if you are just here for the data and want to talk more about that, we can satisfy that craving. All right, so an overview of who we are. Hui Okawaiola means Association of the Living Waters, and that name was gifted to us from Apupuna in West Maui, like I said, where we started monitoring. As the first citizen science-based water quality monitoring program like this in Hawaii, it was really helpful to have 3 partner organizations to get things going. As Larry mentioned, it's the Maui Nui Marine Resource Council, the Nature Conservancy, and West Maui Reach to Reef Initiative. And an outstanding, incredible showing of interested citizens have shown up to volunteer for years now. And that is a really integral part. Those are the feet on the ground, gathering all of that data, which we're sharing with you today. So thank you if there are any volunteers here tonight. We have 4 team leaders, some of whom are here as well, and they help to organize all of those many moving feats and much more. Thank you to our team leaders. And then because the program has so much organization going on, we have a couple hired staff, including James, our project manager. We have a quality assurance officer to make sure all of the data is quality assured, a data manager to help organize it, someone who analyzes it, Kim, who's also our lead scientist, and the steering committee, which is represented by all of the 3 organizations that are partners to Hui Okawaiola. Our mission is to deepen the understanding of Maui's coastal water quality through science and advocacy to accelerate positive change. Before we go any further, thank you again to any funders who also might be here, very specifically the County has been a huge donor, and we have several West Maui supporters, including Honoka High, Makana Aloha, Point Paddle Sports, Napili Bay and Beach, and North Beach West Maui. So thank you, West Maui, for showing up to support water quality monitoring in this region. The funding is so important because it is a citizen science-based organization. Our main funding comes from grants, from donations, and what we call an adopted beach program, which we'll touch on a little bit. But if you are really compassionate and tied to an area and want to see water quality monitoring continue there, adopting a beach is a really great idea. So why water quality? Why does Hui o Kawaiʻola exist? Very simply put, the quality of our water equals the quality of our life. And it impacts humans, but it also impacts our coral reef ecosystem, which probably don't have to tell this audience is really important to all of us. We are surrounded by coral reefs, and just to highlight a couple of the key benefits, they are the first life mentioned in the Kumulipo, which is the Hawaiian creation chant. So culturally, the coral polyp is where all life originated. So pretty important and powerful and pivotal. It dissipates 97% of wave energy, so any coastal infrastructure, they provide a really valuable barrier to that. And then specifically for West Maui, a study just came out from the Nature Conservancy and USGS that the coral reefs in West Maui prevent $85 million in damage every year. Damage prevention, so very highly valued. Coral reefs generate more than $1 million a day in Hawaii. They feed people and our food chains, and of course, are critical habitat for our marine life. So 100% of what Hui o Kawaiʻola does supports the state-led Department of Health Water Quality Branch. And it is one of the many jobs of the Department of Health to monitor our water quality. It is a very big job though, and so there's an invitation for support. And Hui o Kawaiʻola exists to help support this effort. So in essence, all of the volunteers have been stepped up. They've been trained to the standard of a state employee to gather quality assured data. And it's been an incredible partnership to work with the Department of Health to write what is called a Quality Assured Project Plan, or a QAP, which Kim will talk about, QAP. And the QAP essentially outlines all of our monitoring, all of our sampling, how we process everything, so that we are in line using the same lab, the same equipment that the DOH uses, so that all of the data can be held hand in hand with theirs and sent to the Environmental Protection Agency, the EPA, along with DOH data. It's pretty awesome. We sample for 13 parameters. Kim will also dive into that in the technical section. And currently sample 39 sites from Honolua Bay all the way down to Ahihikina'u Natural Area Reserve. I believe just added a couple sites in Ma'alaya too, but that data is not included in our presentation this evening. Something we're really proud of is all of our data is publicly available as soon as we can get it to you, which turns out to be quarterly. And when I say the data is publicly available, it is presented in an Excel spreadsheet. So if you're looking for a quick summary of an answer, that is not what you're going to find if you download the spreadsheet. It's if you want to play with data and generate your own graphs, that is there for you. And that is really unique in any data collection effort. However, if you would like a quicker summary, thank you for coming tonight. We hope to provide that for you. And we also just came out with our annual report, which we probably have Amy's got that over there. You can scan it or check out the hard copy. You can also find all of these things, the raw data and the annual report, on our website, huiokawaiʻola.com. I'm going to pass it over to Kim to dive a little deeper.
Thanks so much, Lauren. Okay, so now, what are we doing? What does the sampling mean? When we're talking about water quality, it could mean a bunch of different things. But in the very beginning, because we decided that we wanted to collaborate with the whole State Department of Health, our mission was to try to have data collection that was comparable to theirs. And so in the picture on the left there, you can see our volunteers at knee deep in the water, and it's going to be ocean water. So we're sampling in coastal waters at knee deep depths. There has been some talk about maybe getting more than this, but that allows us to kind of match our data set to the Department of Health and really have a standardized place where we can sample every time. We're also not in freshwater, so we're not sampling streams right now. At some point we might be, but we're not sampling streams right now. We sample every 3 weeks. In the past, we used to sample every 2 weeks. And the reason we used to sample every 2 weeks in the beginning is because we wanted to really understand what the tidal cycle would do. If you sample every 2 weeks for a long time, you're getting only samples on the new moon, full moon, new moon, full moon, or something to that effect. And so we decided after a couple of months of getting that data like that, that we would start to see the influence of different tidal states by sampling every 3 weeks. The picture on the bottom shows that often we'll be sampling out of the backs of our cars and prepping all of the samples, so we have a mobile lab that goes out to each site. And each team is sampling about 5 sites at a time. Alana already mentioned the QAP, so the Quality Assurance Project Plan. We're proud of having a QAP, having a plan when we sample, because we are the first community group that really has access to being able to say, we've done our data, we've collected our data, we have validated our data, and we can really say from a regulatory perspective that our data is true and as good as possible. And with this document, in the picture on the left, you can see us, it was signed, it has to be signed by the Hawaii Department of Health. We can submit our data to the integrated report. Now, being able to have regulatory quality data means that you can also back up some of the actions that you would want to see from that data, right? That nobody can really question your numbers. They can question your sites, or they can question other things about your data set, but they can't question how it was taken. And the volunteers are really the core of this in that they do all the hard work of calibrating, verifying, taking extra samples to make sure that that data set is really, really what we say. In order to get volunteers trained up to this standard, at first we did annual trainings that lasted somewhere between 12 hours, something around there. But today's system has you guys going out, and if you're interested, then you get to shadow a trained volunteer and then work with our handbook to make sure that you understand how to do it, and then follow up after that so that you can really learn in stages to make sure that you really want to become part of this program. That said, every volunteer really has to know the steps in exactly the right way so that we can really show face to the Department of Health and say, yes, we're following our quality assurance guides. So over time, we've developed a beautiful handbook and this sort of thing so that we can really make sure that we get our steps all down. But what do we sample for? What is everybody doing? We sample for physical parameters, chemical parameters, and very soon we'll be sampling for bacterial parameters. So physical parameters are things that you can measure in the field. You take a bucket of water and you can tell just from that bucket of water and some fancy sensors what the pH of that water is, what the dissolved oxygen is, what the salinity is, what the turbidity is, the temperature. So why do we want to care about all these things? The pH will tell us whether the ocean is getting more acidified over time, which is an issue. The temperature is going to tell us whether we have increasing or decreasing temperatures and whether we're having more signals from different other parameters at the same time. Salinity shows us when the most recent freshwater pulses are and how much groundwater we have. And dissolved oxygen is usually a metric of showing how much oxygen is being used by either mycobacteria or by microalgae. So all of these different parameters are helping us understand what kind of the state of the water is. One of the more interesting ones for West Maui is everybody here has seen the groundwater events. And so turbidity is a measure of how clear the water is. In other places, turbidity might also include how green the water is, right? Have you ever seen a pond and it's kind of green? That can also be a measure of turbidity. But because we generally don't have a lot of microalgae in our water, turbidity here stands in for a really good metric of how much sediment you might have in the water. And then the chemical parameters. We can't do this ourselves, but we do filter in fields. So it means we're getting the samples prepped and ready to be sent over to our lab on Oahu at S-Labs. And for these particular parameters, we have nutrients, so including nitrogen and phosphorus, and silicates. Silicates are an indicator of groundwater. So when it rains up in the mountains, the water percolates down through the earth, and as it goes down through the earth, it picks up silica. So if you want to know how much of a groundwater influence you have on your site, you look at the silica reading. For the nutrients, nitrate is the one that we usually look at because it's bioavailable. That means all those little microalgae in the water that I said Hawaii doesn't have all that much of in the coastal zone, they can eat them right away. Nitrate is really bioavailable. And it means that if you have a lot of nitrates in the water, then the reef itself can have too much micro or macroalgae, right? If you ever see macroalgae on a reef, chances are it's able to overcompete over coral because it's able to suck up those nutrients faster. Or if you have a lot of nitrogen in the water, it might include a bacterial growth. Just like if you had too much of something you didn't like in your water, you might get sick, right? Well, nitrogen is something, it can feed the bacteria that would make corals sick as well. So phosphate comes down with water, and again is an indicator that could increase some of these bacterial or macroalgal overgrowths, which make corals not so happy. So these are all the things that we're measuring for, and in the near future, we're going to be looking for these indicator bacteria, because human health is also important. So Enterococcus and Clostridium are two indicator bacteria. And I say indicator because you really can't measure bacteria very well in the ocean, because there's lots of bacteria. But these indicator bacteria are used as saying, okay, this is a stand-in, the best stand-in that the EPA says that we're allowed to use. And if you have this stand-in here and you measure this one type of bacteria, then it represents how much of a sewage input you might have to the site, or how much bacteria you might have in from goat poop or pig poop or some other type of sewage. So these are indicator bacteria, and we're really excited to get this program running as soon as we can. What we don't test for, though, is probably a longer list. And the reason we're not testing for radiation, heavy metals, or pesticides, or sunscreens, or these types of other parameters, which are still important to the reef, is that they are harder to test for, and that they're really expensive, some of these tests. They can run $1,000 to go through a whole site. It can be very expensive. We don't necessarily have all the equipment we would need to sample and to measure for these, and because the expertise in looking at the analysis might not be what we want. So our success has been in partnership, in partnering with universities and partnering with other academic researchers who may do these tests to try to get them involved in West Maui. And TOVA in particular has been good about those sorts of collaborations with the USGS and the University of Hawaii at Manoa and others to try to get more information so that our data becomes amplified, or that our data can serve as the base for more complicated analyses that are being performed. I guess the last thing I just wanted to mention is that there is a statewide initiative right now to look at cesspool discharge, and maybe we can talk about this later, but Act 125 is really looking to figure out what the effects of cesspool are. And so there's some of that data out there too, and that's been a good partnership to date as well. So that will be one of the next things that is happening in the very near future. With that, I'm going to pass it off. Who's going to talk to you about the data?
Hey everyone. So I'm just going to go over a high level of our data results. And if you guys have more specific questions, you can either ask after the presentation, or we have a data section or a data station over there that you can ask as well. So I know that this is about West Maui results and not South Maui. We do have 20 sites in South Maui that we test at. And the main takeaway from South Maui is that the nutrient levels are really, really high. In fact, compared to West Maui, the highest nutrient level site that we have in West Maui is only 1/3 of the highest site, which is Cove Park in South Maui. So West Maui, our biggest concern is turbidity. Turbidity is the clarity of the water, like Kim said, and it can lead to brown water events, which is a big problem we have. I don't know if anyone recognizes this bay, but it's Honolulu Bay, and this is a classic brown water event. And so the Department of Health, they have a clean water branch that monitors, and they also set standards for all the sites. And according to the Department of Health, every one of the sites on the west side is tests higher than it should for turbidity, meaning that every single site is impaired for turbidity. And you guys keep this picture in mind because we're going to come back to it. So this is just an overview. We're going to dive into the Pacific sites a little bit more, but this is just an overview of every site that we test at. And it starts at Honolua, and it goes all the way down to the Pali. And so the state, the Department of Health, they use what's called a geometric mean as their metric for our further water results. So this is about 3 years worth of data. So if you notice, like at Honolulu, it goes up to about 11 on the y-axis. Well, that's 11 NTU. And NTU is it's just a unit used to measure turbidity. Now, the state standard is 0.2 NTU. So according to the state, anything above this red line, which is 0.2 NTU, anything above 0.2 NTU, the state says is impaired. It says that there's something wrong with that site. So you'll notice, again, every single site we test at, they're all impaired for turbidity. Now the gray bars, they're sites that we used to test at, but the Department of Health has taken over testing. So it would just be redundant if we have that overlap. So now, that was turbidity. So now let's talk about the geometric mean, which again, geometric mean is just an average. The geometric mean of nitrates plus nitrates. So here the state standard is 3.5 micrograms per liter, which is the red line right here. The takeaway from this graph is that, so Lahaina is somewhere around here. Now you'll notice, so this is from north to south geographically, our most northern site to our most southern site. You'll notice that where Lahaina is, everything north, you can see that's where we have a nitrite issue here. And why is that? Well, where do people live? Where do you have human activity? So from Lahaina north, that's where you have all the big agriculture, and we still have we call it legacy ag. So we still have problems, even though we don't have a big agriculture there anymore. We still have issues, just things that have been left in the soil that come out. So now we're going to dig. So we're going to split this graph up, and we're going to dig into it by geographical region. So here, this is Honolua to about the beginning of Kahana. And what we have here, we've taken the state standards. So the state standard is still the red line, and we've normalized it. So what's going up, this is how many times you're over the state standard. So, and we have turbidity, and then we have nitrates. So this is just going to give you an idea of all the sites that we test at, what's the bigger issue, what's the bigger pollutant. So, say you're looking at Papalaua. So here, the turbidity level, what is that? That is about 48 times the state standard. So that's 48 times what the Department of Health says is an acceptable turbidity. And then also you can look at the nitrate level. So the nitrate level is about 15 times. So it's about 15 times what the state says is an acceptable level. So Honolulu has a big stream coming out into it. So that's going to bring down a lot of sediment whenever you have a rain event. So now moving along, this is Kahana Village to about where the post office is. And so the next couple of graphs, they're all going to have the same format, where you have the state standard, and then the green is how many times the nitrates is above the state standard, and then the brown is how many times the turbidity is above the state standard. Oh, I will say that Pa'aku, which is esterns, on the west side, that has our highest nutrient level, which is interesting because there's no stream that comes out, there's no stream that's affecting that site. That has a lot of submarine groundwater discharge. So now moving on. So you notice from the last slide, so we look at our green nitrates. Well, now we're getting to the south of Lahaina. We're getting to the south of Lahaina, and so our nitrates are not really becoming an issue anymore, but now it's the turbidity. And what we have going on over here, we have an offshore reef that traps in a lot of the sediment and keeps it there. And then also we have a lot of stream activity. And then moving on more to the last sites we test, same thing, we just have a lot of stream activity and we have a lot of runoff areas. But nitrates aren't really an issue. So now, so this is interesting. So this right here is a geometric mean that we've been talking about. So this is a geometric mean, which is a type of average. And what's interesting is that this is every single data point we have. So every one of these points is a sampling session where we've gone out and sampled. And what's interesting is we just wanted to show the variation that you could have. So even though we talk about the geometric mean because it's just the best average we can use, you still have a lot of variation. Like this goes all the way from 325 micrograms per liter all the way down to almost 0. Depending on if it's high tide, low tide, if there's rain events, if there's big surf. So now, Honolulu Bay. So we're talking about turbidity. Turbidity is the clarity of the water, which this is always interesting to me because this is such a big snorkel area. And we actually, whenever we test at this site, it's one of our earlier sites because we have problems parking there because it's so popular. But, so there's only a couple of takeaways here. So whenever the turbidities jump to 160, well then that's a big rain event. So let's talk about turbidity. Turbidity is, so the state standard is 0.2 NTU. Anything above 1 NTU, you have trouble seeing. So if you're snorkeling, if it's above 1, you're going to start to have problems seeing. If it's above 2 NTU, you know, your vision or how far you can see is, it's not going to be very far at all. So 160 NTU, that's like chocolate milk. So that's one takeaway. And then another takeaway is, look where the areas where the turbidity is so low. So where the turbidity is so low, that's all the summertime. This is summertime, summertime, summertime. Meaning that, so another thing that Honolulu has in the wintertime, they have the northwest swell come in. That's why you see all the surfers there in the wintertime. So pretty much the takeaway here is if you guys want to go snorkeling, you have about a month left. And then this is the last thing. So this is temperature. So this is at Pali Bay. And so there's two takeaways here. So first, the red circles, they were all taken in late June. So also, every single dot is a sampling session. So we go out every 3 weeks, so every single dot is 3 weeks. So if you'll notice, there's sort of an upward trend to where here in June 2019, it's 3 degrees higher than in June 2015. But also, and Kim touched on this, the big problem with the temperature, once you get over, so over here we have degrees Celsius, this is 27 degrees Celsius. Once you get over 27 degrees Celsius, that's when the coral start to become stressed enough that they can release their algae, and then you have a bleaching event. So in 2015, you can see for a couple of weeks, the temperature was above 27 degrees, and we actually had a big bleaching event. And now, if you notice, in June 2019, so usually the highest temperature on Maui happens around September or October, but you can see we've already surpassed the highest temperature for the last 4 years. So the question is, are we on our way to another big bleaching event? Now with that, oh, and also, so this temperature chart, pretty much any one of our sites, the temperature looks like that. I just picked this arbitrarily. Now we're going to pass it over to Toa.
Thanks, James. So, James has walked us through all kinds of different issues. You can see the data is pointing to a lot of different sources. So what does the WHOI stand for? We stand for anything that's supporting clean water, whether that means cleaning up on-site sewage disposals, having an alternative to injecting wastewater, addressing the sediment coming through the streams, could be with BMPs during construction, any other time. Hui Vai'ola is backing those various efforts and hoping that they take place. So what is the next step for the WHOI after we have this data? You can see that the data we're collecting gives baseline. It's not in and of itself drilling down into what the problems are that are driving those areas of violation of the state standard. So that next step of using it to direct research is both internally, the additional looking that we do. So James mentioned that the legacy agriculture is still a likely suspect for the high nutrients. That was looked at in a number of ways. One of the ways is graphing the silicate level, which is a tracer of groundwater, to the points where we have the elevated nitrates, and they graph out together very tidally, meaning that one is very much related to the other. So then we can understand, okay, this is a legacy issue with the agriculture, and we can figure out, is there anything we can do or not? So in some cases, we're trying to do that additional inquiry. In other cases, it's about getting the data to our research community and the other partners that we have who can have that as a jumping off point for getting at what needs to be done. The data is also collected with the hope of being a tool for making better decisions at the local level, whether it's county or state. I see we have Pam there, which is great from the planning department. Sorry, I had to call you out, but the West Maui Community Plan, for example, now has a data layer that they can look to and see whether or not there's parts of the coast that should be given special attention in that process. And that was something that wasn't provided with the level of information included that we now have for that area. So our hope, each of us who are a part of it, and now you who are now aware of it, hopefully will become advocates for making sure that whenever a data set related to coastal water quality is relevant to decision making, you know to direct people to Hui Vai'ola, where you can find that. And of course, it's not just about finding what the problems are, it's about dealing with them. So in the case of West Maui, we are lucky to have a number of efforts that are focused here, specifically on land-based pollution. Ekolu Lindsay and his family has been focused on trying to figure out how to address issues in their part of Lahaina town. Farther north, in the area that I work in, the West Maui Ridge to Reef has been focusing for the past 7 years and change and has about 20 projects that have already taken place to address land-based pollution. And there's a need to bring more partners on board. You can see that Hui Vai'ola is very focused on the data collection portion of it. It's a limited amount of capacity. We need to leverage everyone else in the community to actually address what we find as problems. And while it's a nice distinction to be the first group to have a quality assured community-based water quality program in Hawaii, the idea is not that we are the last. We have been sharing this information out through webinars, at conferences. Kim has been great through her network at TNC in getting the word out. The hope is that this sort of effort, by being shared in all of its steps and all of its protocols, can be replicated in other areas. And the whole issue of tracking and managing a cleaner ocean is adopted broadly. And this has been mentioned before, as much as it is a volunteer-based effort, we were surprised, really, in the first year to discover that there still are a lot of costs associated with it. There's the physical costs of doing the testing, of shipping it off, of having the analysis run of the materials, and also of needing to have staff that's dedicated to making sure the standards are upheld. So an ongoing next step for us will always be to try to generate the $4,000 per site per year that it needs to allow us to continue to take that baseline monitoring step. So, as a recap, you've heard from my friends here, it's all driven by that community interest in better understanding what we have going on. It involves a lot of very talented and dedicated people who are highly trained, working on the right equipment to be quality certified. We rely on lab space generously donated by partners, including Lahainaluna High School in this case for our West Side lab. We have that quality assurance plan. We're reliant on funding, leveraging partnerships as much as we can, and managing the data, and all of that together gives us better insight into what's happening in the coastline so that we then have the tools that we need to manage it. You can only manage what you measure, so without that first step, we aren't very far towards that managing piece. So I am going to turn it over to Amy, who is there.
Thanks, Tova. Hey everyone, I'm Amy with the Maui Nui Marine Resource Council. I just want to give another shout out to our supporters of the program. We've heard the cost is $4,000 per site. We now have 41 sites as of this month, so you can do the math on that. But I just want to mention, again, the Mayor's Office of Economic Development with Maui County has been with us from the start for years now, a strong supporter of the program. Like they said, we have Honolulu Bay, West Maui Community Fund, North Beach West Maui Benefit Fund, who else is over this side, Makana Aloha, and Lush Cosmetics is a business that has been supported us for this last year, and a great sponsor, so they're actually right down the road here if you want to go support them. They were wonderful for us. So we're always looking for more supporters, and with that, I think we're going to move into the questions and discussion section. Now that you know who we are, what we do, how we do it, and you saw a sneak preview of some of the data that James shared with you, we'd be happy to use the minds in the room to help answer some of your questions. So we can do that. We have 2 microphones. We can, Larry will help facilitate that.
I just want to back off a little bit. We've kind of very matter-of-factly presented a lot of awesome information here tonight. But the information wouldn't be possible without a lot of people in the audience tonight who have given up their time, their energy, their inspiration to help this program become successful. Can I just ask everybody who's helped us and volunteered, can you please stand up and get a little bit of applause? Woo! Can we give them some aloha, everyone? Amazing group of people. This is a spectacular program. I mean, it's just fantastic. We should all be very appreciative and humbled by the dedication this group of people has shown. Okay, questions?
When we look at the state standards where it's very, very low, seems an impossible place for us to reach at some point. Are those taken also at knee-deep water? Are they taken in 10 feet of water? Are those tests taken at the same sampling that we do?
So, sorry, this is Kim. Hi.
Hi, Kim.
This is a great question. So yes, right now the Department of Health has always been the way that those standards are, the program that this all goes with is the Beach Act. So sometime in, I think, the late 90s, I hope that's right, the Beach Act was formed as a branch of the Clean Water Act. So it's a federal program sponsored by the EPA to have water quality testing. And so these numbers comes from kind of EPA level, and then there was a reanalysis done for Hawaii along somewhere in the late 70s on what these water quality standards would be, something like this. So given all of that, yes, the state is using knee-deep water for this. I would say that the EPA has asked the state to reevaluate, because once a water body is considered impaired, then it has to go on is impaired for some amount of time. And the state really doesn't want to have impaired water bodies either, right? And so the EPA has come and asked the state to do a survey, and that this will be happening in August, and they've chosen Honolulu Bay on Oahu first to compare inshore and offshore samples. So samples taken less than 30 meters of water versus samples taken greater than 30 meters of water, to try to figure out if that statistical difference, really what that looks like. Because obviously, it only seems, if you're taking it in knee-deep water, I also feel that the state standards are impossibly low, right? But that if you swim out into the middle of Honolulu Bay, maybe then those are standards that apply. Or maybe if you're swimming out to the reef crest, maybe those standards are attainable and also reef-wise, right? So I think this is an issue that the Department of Health is considering, or at the very least, the EPA is asking the Department of Health to consider.
Thank you.
Other questions? Mike helps.
So with all this data of turbidity and nitrate, are you guys going to offer resolutions or make suggestions on what the state or county or community can do to eliminate or reduce all this turbidity and nitrate?
That's a great question. When we're talking about leveraging the local partnerships, to date, it's mostly been about trying to figure out who's appropriate for addressing it. Sometimes that will have a policy solution. Sometimes it will be looking on a very specific project, like changing the amount of sediment that can be trapped in a dam or something like that. A lot of these sources of pollution are a little bit trickier to just call to task because it's an on-point source. And so working through partnerships is often the way, and watershed management planning, and this kind of is the way that the state is approaching addressing these issues too. Advocacy is a part of how we want to be positioned within the community, but to date that hasn't necessarily translated directly to policy. Pam, do you have a follow-on on that?
Great question by Joe, who is a CPAC member. Yeah, just threw you under the bus. So with regard to non-point source pollution, and I'm tagging on his question, which was a really good one, is since you guys have data, which is great, my hope is that as we're going through the update of the West Maui Community Plan, you guys can make suggestions with regard to policies and implementing actions in terms of how land use impacts water quality. That's going to be really important. Whether it's nitrate-based, meaning legacy issues, or actual land use based, which is what I think the gentleman in the middle was referring to with regard to where you have development. Because one of the things that we do in updating the West Maui Community Plan is we're looking at the future growth and protected areas that were cited in the Maui Island Plan. So what the community plan does is assigns community plan land use designations. And what that means is what, if any, development do you want to have in these areas cited by essentially the county council in terms of residential, density, commercial, retail, whatever. So your information, and thank you so much. Before coming to Maui, I was very involved in beginning a citizens monitoring effort in Rhode Island. And I want to thank the volunteers. You guys have no idea what you do is so critically important. Because ultimately, them getting you guys the results, the information, the data is going to hopefully change and lead to policy and management decisions. So tagging on that first question I asked you is, would you consider doing a presentation on this, which is so valuable to the decision makers? Decision makers, folks, is not the planning department. I know we're an easy, convenient target, right? I'm here, you can attack me. But we're not the decision makers. We do write staff reports, absolutely. But the decision makers is the county council and it's the planning commission. So I would encourage you to find a committee, and I'm sure Councilmember Paulton, being the head of the planning land use committee, would be sympathetic, but I really, this is great information, and thank you. And there's obviously a very strong nexus between land use and resulting water quality. So I would encourage you to make a presentation to the appropriate county council committee and especially to the Maui Planning Commission. Thanks.
Thank you. The answer is yes, absolutely.
Yeah.
I wanted to add a little bit more context. Our kuleana is to gather and evaluate the data. That's where our strengths are, that's what our focus is. We are working hard to partner with other organizations who have expertise, both in the scientific community, in the policy community, and in the regular community, people who have understanding of what's going on the land much better than we do. We're focused on the water. And so we will always be interested in partnering with and helping the other groups who have that expertise to draw the right conclusions and to make sure that they understand how to interpret our data. But this is not something we can do alone. This is something that's going to involve government agencies, developers, the hospitality industry. It's going to be a big, complicated thing to make proper use of all this data. And we're on it, but it's going to help us spread the word, help us get everybody else involved, because it's that big a job.
So my question is, how many sites do you guys have? I know you have West Maui and South Maui. Do you have any other sites in Hawaii?
We have 20 sites on the south side.
Okay, maybe I should say how many other, are you guys monitoring on the other islands or just Maui?
Oh yeah, our plan was written for just Maui. On the Big Island right now, I think there's a list of 70-something sites, of which maybe 10 are currently actively sampled, and they're moving towards filling out a Honolulu side, Hilo side, Kona side, and Pali side. So they have different, it's the same sort of structure. In Honolulu, on Oahu, they're doing the same thing. Pearl Harbor, West Lock, they're trying to do the same thing. But all these groups are far behind, and their data isn't nearly as accessible as ours yet. If you have suggestions, I'm curious to hear.
No, I'm just going to throw this question out, and I don't know if you're going to have to answer. So the turbidity areas that are high, are you going to say is more runoff from, say, agriculture and development? And the nitrate sites that are high, are you going to maybe suggest that it's from runoff from golf courses or to that extent?
The most recent data is showing that a good portion of the nutrients, the nitrates, are coming from legacy ag. So when they put all the fertilizers on the pineapple and the sugar back in the day, it takes a long time for that groundwater to clean itself out, right? And so almost you can see in our differences between South Maui and West Maui. South Maui just stopped last year, right? It's really recent, and the nitrate levels are much, much higher. Of course there's a contribution from golf, and of course there's a contribution from every little thing that goes into the wastewater contribution, right? People have cesspools and septic tanks on their property, or if the wastewater is maybe not being discharged in the right way. So all of those things have the potential. But when we look at the data overall, right now, it's leaning towards, it's in the groundwater, and so it's a little more diffuse of a problem to be able to solve right now. Does that mean that it's continually going to maybe either go down, or that we're going to have added human intensity issues to make, say, the golf course issue worse or something like that? Like, those are solvable things. It's pretty hard to solve the legacy effect in the groundwater. On the turbidity side, we all know that when it rains, we have groundwater events. And I hear people saying that the groundwater events are getting worse. And so the USGS in their study found that most of that sediment directly would come from, again, a legacy issue a little bit, and that what's in the channels right now is stuff that was pushed over the hill when they were farming and terracing out all those fields. So it's one major source, and it's a hard source to get out. The other source that I think is also happening is that there's degradation in the upper watersheds, right? As time goes on, there's more pigs and there's more deer and there's more, all of the ungulates upwind that are kind of causing this degradation that can also cause effects down. I think the lack of management in general of these lands over time, since things have changed, may lead to some of this. And I'll leave it to Toa, because it's not like the scientists have come together and like hit hammers down and are like, this is the answer, right? They try, they definitely try. But it's harder than it sounds when you have so many different pieces moving. But the best available science right now is saying that those are kind of the players in this game. And so being able to kind of continually go after all those pieces in check, or to use the reservoirs that we already have to hold back some of that sediment or slow water down. Every little bit of impervious surface that people have on their property makes water go faster, right? Half of the point of development is to make water go fast. If you slow the water down, it gives it more time to percolate, it gives it more time to get treated. So in terms of like what can we do from a land use perspective, that slowing the water down is one of the best things. And it's not so easy if you don't have land where you're needing to do other things. Sorry, that's a soapbox, but maybe Toba has more things to say.
into our data table, and we'll show you what puts different sources in or out. It's fascinating. Yeah. Maybe you moved on. A different question.
Yeah, it's interesting that you're talking about slowing the water down because in the Ahupua'a system they had terraces and terrapatches that slowed the water down. Thank you.
Oh, sorry, just to take one more thing on the sediment issue. Increasingly, we are seeing a coastal turbidity issue driven by wave events that are accessing that fine loose sediment where the underlayer is not sand. So in Kahana, you go to Pahaku estuaries, looks like blood in the water sometimes. There's no inlet coming there. That's just what's getting carved out. And you saw in the numbers, oh, you have it there, probably can't read it, but it's one of the higher sites, and there isn't even a stream channel coming in. So the sediment issues, those are kind of the two. We haven't done an analysis of figuring out what the magnitude is coming from what, but I've been shocked even just in the last half a dozen years focusing on this, how many more groundwater events during sunny days there are in West Maui.
Michelle, anyone else? You're too popular.
This is a question I've had for a long time, because I did the Uluwatu area for testing. There is no porta potty from mile marker 11 all the way to Waikoko. And on weekends, there are hundreds and hundreds and hundreds and hundreds of people camping there. And is there anything we can do to provide, get the county to provide more porta potties and more disposal systems for all of the trash and garbage and stuff that's left on weekend, well, all the time, but on weekends? Because, we go out water quality testing and we've seen things in the water that you do not want to be swimming in that water. Like a Band-Aid on a really big issue, I know.
Sounds like a fantastic opportunity for a partnership to have a group from the community who wants to focus on that problem. It's a problem.
Oh, yeah.
Hi, just to follow up on the turbidity. That load of sediment that comes out after a rain event, do you know, does it eventually flush out to sea, or where does it go?
So the U.S. Geological Survey has recently done a circulation study. They've done the data collection side of a circulation study to try and kind of figure out that fate and transport piece. Because we're looking at coral reef health, and it only matters if the sediment actually is landing on a reef. Unfortunately, that study is not out yet, so stay tuned. In the nearshore water in West Maui, there is a pattern of things moving from the north down to the south, with a few areas like Pink Beach where there's eddies. But in general, that's the direction of the flow. Beyond that, we'll have to wait for the study to come out and inform it.
I'll have a non-sciencey moment and just tell you hearsay. I've heard from people who dove out there that there are pillows of sediment offshore down on, kind of clearly land-based sediment that have settled offshore. So only from observation I can say that's a thing that people have observed. So that said, Maui Nui is interesting in that it is kind of an enclosed space compared to some of the other places in the Hawaiian Islands. There are lots of other places that have much worse sediment problems, but it gets whisked away really quickly. And so, as James so kindly pointed out, when you have that nearshore reef in there and it gets trapped, like Pohaku is a good example, right? It's in there and it gets trapped. That's when things get bad for the reef. And then if it gets out into the channel, I don't think it has as many opportunities as it would say on the east shores of the Big Island for stuff. I wanted to just give a quick answer to the poop question for Uluwatu for the new bathrooms problem. I have done the math on it for Lanikai, and it didn't come up to be a huge percentage of the budget, but really you're still relying on, what's that? I did pee, this is a good question, so maybe. There could be, yeah, so there could be an influence, but yes, focus on the bathrooms if possible.
One thing is, in places where the sediment isn't washed away, The runoff sediment can be very finely textured. They're called fines. And what we find is that when there is wave action, if the sediment gets elevated back into the water column, and the fines will often stay in the water column for an extended period of time. The implication for coral is that the information for snorkelers is that the water has higher turbidity. The implication for coral is that they don't get as much sunlight. So it restricts their growth, restricts their health. And those fines can be resuspended many, many times before they're finally dispersed.
We have a question over here.
I don't know if y'all can answer this, but I've heard stories about staph infections from the coral. And is there places where it's worse or better, or does anybody have any information on that?
I know that just because coral do have toxins in them, or the bacterial communities that are in them that are particular to the coral. And so the best that I can offer you is that, yes, getting cut by coral is usually, from what I've seen and what I've read, a pathway to infection pretty quickly. So I don't think it depends though on where that is necessarily. Of course, staph infections are more common in places where you have wastewater problems. So there is a correlation there, but getting cut by coral is generally likely to can cause infection just regardless because of the bacterial communities that live with the coral system.
So in waters here known to have staph, do we really bad?
Do we have staph, is the question. Are we really bad?
Yeah, Amy could probably answer.
Just inspect my body.
I would say every paddler friend that I have has had a staph infection.
Oh, lovely.
Yeah, and typically, like the advice from the DOH, the Department of Health, is if you see brown water, don't go out. Because sediments tend to be this little thing that bacteria, that heavy metals can cling onto and catch a ride out to the ocean. So if it's really murky water, you don't want to go swimming in it, because it's more likely that you are to get an infection.
But even the clear water.
Yeah.
Even the clear water. Like James said, you have like 1 month left to snorkel before you're in the turbid water at Honolua. So you're hedging your bets. Anything else or no?
I was just going to say freshwater is usually the vehicle for these sorts of bacteria. That salt water does kill a lot of things, which is why. So the saltier it is, the better. I'll go for that.
Thank you.
Other questions? Breakout time, you think? Oh, okay, we got one in the front.
So other than like marine or coral health, what are other implications of turbidity and high nutrition levels?
I think that we've gone over the fact that sediment usually is bound to other things. So sediment bound phosphorus, sediment bound nutrients is common. So all of the sediment, most of the sediment that's coming down because it's made of iron and aluminum, that redness that you see, makes it really sticky. Have a lot of places to stick, and so then the nutrients can bind onto it. And then that sediment, as it falls to the bottom, can be released. So that is still a coral thing, and that you're really adding nutrients to the water. But as Alana said, if you want to go find metals, or if you want to go find any type of pollutant, go look for sediment. It's a good vehicle for a lot of pollutants to get into the ocean. Not all, I will say that. There's definitely pesticides and herbicides out there that aren't going to be traveling by sediment-bound processes, but that having sediment is usually an indicator of maybe other problems. So that would be my number one.
Last question.
Oh, okay.
When do you expect to have results on bacteria?
When will the bacteria results be in?
So we're going to start on the south side of that, and we actually plan on, we're on a 3-week sampling schedule, and the next time we're going to sample on the south side, we just finished last week, so in 3 weeks, in 2 weeks, and we plan on starting the Enterococcus, which Kim brought up is an indicator bacteria. So we're going to be looking for that, but we still haven't decided how we're going to disseminate that information.
The Department of Health is measuring enterococcus on how many beaches?
Well, the tier 1 priority site.
Yes. So the DOH right now, they're saying that they measure most consistently every 2 weeks, I'd like to say.
I think it's every week.
Every week. I was being generous, every week. So the Department of Health really is measuring for enterococcus because the Beach Act was meant to protect human health, and so their tier 1 sites, they call them, target beaches that humans most use, that people use. And so they're still sampling at the most popular beaches. And you can get their alerts online if people haven't done this already. You can sign up on the Department of Health website and get an answer. I forget how you do this. I can answer you with the data table. I'll look it up on my computer. But if you sign up for their address, then they'll tell you every time any parameter is over at any of their couple hundred sites across the state. So it's sort of useful if you want kind of real time. Real time minus 24 hours. It takes 24 hours to do the test and then give them another 6 to 12 hours to post it. So there's some delay there. But that website in particular and getting them by email information has been pretty useful.
We have a link to that site on the Ho'okabai data page. So yeah, check out some data and sign up for the alerts.
And I know Honolua and some others are sites because when they go off ground, you'll get the DOH warning within a day or less. So.
Okay. Oh, sure. One more.
Why did you not test on the North Shore?
Oh, okay. This question comes back to how many sites are we doing and where are we doing? So we've got 20 South Maui, 19 West Maui, just added 2 more Ma'alaia. Why aren't we doing North Shore? Where are we going with things for Maui?
So we care about everywhere, but because you can probably gather it's a fairly big undertaking, we've created a strategic plan to figure out what the pace is that we can grow at and remain sustainable. And it partly is also what partners are at the table too. So ideally, at some point in the future, we'll get to the point where we have so much capacity, so many partners, and so much success in fundraising that it can extend to other areas. But it's at least a few years out. I'm trying to remember when it was in our plan, but I think a few years.
East Maui was 2021, hopefully.
Yeah, so that's a couple years now.
Lahaina and Pali,
North Shore.
Lahaina Bay, all of those areas are really popular. And very, very.
Yes, dirty water, first ingredient, check. The next thing we need are all those other parts. Oh yes, Surfrider.
So Surfrider Foundation currently monitors enterococcus on certain sites on the North Shore. So not all of the parameters that we're doing, just enterococcus. So that is a great indicator if you're curious if it's great to go in the ocean. And
There's stuff is on they have a website called the Blue Water Task Force, and all of their data goes live too. So you can look that up. I mean, their data is just as accessible when they're taking it. So.
That's on your website.
we link to it. We share to the best that we can as a platform to other people doing water quality monitoring.
Okay. Any last second questions? Are we good? We can do a lot more. Okay.
I'm just a little curious. You mentioned legacy agriculture is a major contributor to some of your data. I'm just wondering how much the wastewater found also contributes. Is that equally just problematic or anything?
Point the finger.
It's definitely site by site. Overall.
Do you mean the Lahaina wastewater facility?
That is what we're doing.
So our data point, interestingly, doesn't reveal a lot at the point where we sample. However, being such a hot ticket item, a lot of other science has been done in the area, very specific to what's coming out of the seeps. And there is a lot of information about the whole suite of chemicals that come out with wastewater. USGS study by Peter Swarzinski found at least 20 times the background levels of nitrates coming out, and a number of other things have been found in relation to that area. It's just for our limited number of points and our limited types of tests, we aren't seeing that. If you want more information, westmauiartr.com, got a whole page of publications that speak to that.
We'd probably link to that as well on the Hui site. So, yeah, there we go. One-stop shopping. Thank you.